One of the most important classification in chemistry is the arrangement of elements in the periodic table. Yes, so we'll be considering periodic table today, and our subtopic will be families of elements. Yes, so the modern periodic law is the first thing we should consider. It was stated by Mendeleev, and it says that the property of an element are a periodic function of the atomic number. Yes, of the atomic number. So now in 1869, it was Mendeleev that was able to arrange that, and arrange that in relative atomic mass. Now, when we are talking about elements, every element must have an atomic number and a mass number. Now, the atomic number is the number of proton only in an atom, and the mass number is the sum of the proton and neutron. If you ask me where is electron, don't forget the same figure of proton and electron. They share the same number. I use the mnemonics pen, where P and E, the first two, are usually having the same figure. That's proton and electron. So we shall do this one as a topic on its own. Now, that's for talking about element. Now, concept of periodic table. For the group, we have the group is the up and down movement, the up and down movement of a periodic table. That's where what we refer to as the group. Now, when we are talking about period is left and right. If group is vertical, then period will be horizontal, the left and right movement. So periodic table, how does this thing look like? It looks like this. Yes, it looks like this. See how there are many. So each box looks like something like this, an element whereby it has an atomic number 8, mass number 16, then the short form is O, meaning oxygen. Yes, that's for oxygen. So now, this periodic table, they are very into groups and period, which is one of the most important thing we should consider in this lesson. Now, the groups and period, don't forget group is up and down. So we should know that elements in the same group tend to resemble one another in chemical behavior because they have the same number of valence electron. We'll go to that as a topic. And then element in the same period, they have the same electron shell, the same shell. Don't forget, period is left to right. So for instance, now group is this HLNAK. That's group. Group is from up to down. Then period is from left to right. So group one are called the group one are usually univalent. Yes, they are usually univalent, and they are very, very good reducing agents. They have good reducing agent. Group two, like the calcium and the magnesium. Don't forget, if I say group, it means up down. So the second group, which is this part, the blue part, as you can see in that picture, that's group two. So the group two, we have calcium and magnesium. These ones are divalent. They are two. So they form electrovalent compound. Yes, and they are reducing in nature. Then group three is the aluminium group. Now we are going to be skipping this part that is yellowish, that is in the middle. We call them transition metal. So we'll go all over to this part here where we have BAGAN. Yes, that's where we consider as our group 3. So they are like aluminium and the rest of them. They are usually trivalent. Then we have group 4, group 5, group 6, group 7, and group 0, which is the last one, which is orange in color. So those last one are called the rare gases or noble gases. Why I can call group 7 halogen just simply mean salt former. The halogens are these ones that are green. That is FCBIATTS. Yes, that's fluorine, chlorine, bromine, iodine, astatine. Yes, and the rest. So that's for that. We'll be explaining this very, very well as we progress in this study. Please give us a subscribe. If you have not subscribed, I don't know what you're waiting for. Please subscribe to our channel to motivate us. Thank you very much.